Hello everyone and welcome to our channel, Techie. A special welcome to all the dairy technologists and students joining us. This is class 6 in our dairy engineering series, where we continue our unit on sanitation by focusing on a crucial piece of equipment, the can washer, which ensures the containers for our milk are perfectly clean and safe. We begin with an image of the cans used for procuring milk from villages. These are the typical containers that need thorough washing before they can be reused. The condition of these cans directly impacts the quality of the milk and products stored inside them. They can be made from various materials, including aluminium, stainless steel, tin steel, or plastic. An ideal washer must leave the can in 3 states. It must be clean, it must be dry, and it must be sterile. It is also vital that the outside surfaces of the cans and the inside and outside of the lids receive the same rigorous treatment as the inner surfaces. There are 2 main methods for can washing: manual washing, used in small dairy plants, and mechanical washing. In manual washing, the process starts with the cans being pre-rinsed with warm water at about 32 to 38 degrees Celsius. They are then immersed in an alkaline solution, typically made with 115 to 230 grams of soda ash or washing soda per 45 liters of water. The cans are brushed thoroughly. Next, they are washed with hot water at about 60 degrees Celsius. A final rinse uses water at about 65 degrees Celsius. Sterilization is achieved either by steaming or with a bactericidal rinse, such as a QAC solution at 200 parts per million for 2 minutes. Finally, the cans and covers are dried and stored properly. Moving to mechanical washing, this can be either manual operated or power operated. The main types of mechanical washers are the can steaming block, the can scrubber, the rotary can washer, and the straight-through can washer. A common mechanical process is Mohr's washing stages. This involves a sequence of steps. First, draining at 25 degrees Celsius for 3 to 6 seconds. Then a pre-rinse. Then another drain. Next, a caustic rinse at 65 degrees Celsius for 9 to 18 seconds. Another drain is followed by a hot water rinse at 80 to 90 degrees Celsius for 12 seconds. After draining again, sterilization occurs at 90 to 100 degrees Celsius for 5 to 10 seconds. Finally, hot air drying at 80 to 105 degrees Celsius for 12 to 18 seconds. And a cold air treatment at 20 degrees Celsius for 12 seconds. The first stage in any washer is draining. Any residual milk, cream, or fluid is drained out by placing the cans in an inverted position over a drip pan. Some washers have a drip saver to collect this residual milk. After draining, the cans are automatically loaded into the washer upside down, and the lids are also entered for proper cleaning. Next is pre-rinsing. This involves passing water through a jet to clean the remaining milk film in the can. The water temperature is 25 degrees Celsius with a jetting pressure of about 2.0 to 4.0 kilograms per square centimeter for 3 to 6 seconds. This uses about 4 to 5 liters of water per can to remove all traces of milk. Then comes caustic rinsing. The washing solution is passed through jets at high pressure both inside and outside the can. The cleanliness depends on the temperature and strength of this solution. When using an alkaline solution, the alkalinity should be less than 0.15%. Sodium carbonate with a corrosion inhibitor is suitable, as high temperatures can cause milk stone. Caustic soda must not be used. The optimum temperature for this stage is between 65 and 70 degrees Celsius for 9 to 18 seconds. The solution is drained afterwards. This is followed by hot water rinsing. This stage cleans off the washing solution. It uses hot water at 80 to 85 degrees Celsius, or sometimes 85 to 90 degrees Celsius. This water is also drained after use. Then sterilization takes place. This is often done with dry saturated steam at 110 degrees Celsius for 5 to 10 seconds. Steaming sterilizes the cans and heats them, which helps with drying. The effectiveness depends on the steam temperature, its heat content, and its moisture content. The final stage is drying. The purpose is to prevent metal corrosion and stop bacterial growth. This is done by blowing a jet of hot air at 110 degrees Celsius inside the can. The air's moisture holding capacity depends on its temperature and relative humidity. Now let's look at specific washer types. A can steaming block has a stationary part made of cast iron and working parts of stainless steel. It holds the can in an inverted position. Water and steam lines are connected at the base through spring-loaded valves operated by pedestal levers. The top has a concave surface with a spray nozzle, a drain hole, and a seat for the can mouth. A can scrubber is made of 10SWG galvanized iron or mild steel sheet painted with epoxy to avoid corrosion. It consists of a tank with revolving nylon brushes mounted on shafts. The shafts are enclosed in sealed casings with bearings and lubrication points. Cylindrical nylon brushes revolve at 80 to 100 revolutions per minute in opposite directions to clean both sides of the can. The tank has steam and water connections for making warm water and a drain valve at the bottom. To work a can scrubber, you clean the tank and close the drain valve. You open the water valve and fill the tank to the marked level. You add 0.8% washing soda and 0.2% trisodium phosphate to the water. You open the steam valve to raise the detergent solution temperature to 55 degrees Celsius. Finally, you start the rotating brushes using the handle or switch on the drive motor. For larger operations, there are power-operated mechanical washers, the rotary can washer, and the straight-through can washer. A rotary can washer has a large rotating table where cans are placed upside down. The platform moves continuously or intermittently. Below it, a series of tanks contain washing solutions. These solutions are forced at high pressure by centrifugal pumps through jets below and to the sides of the cans. A high-speed blower provides hot air for drying. The capacity is 3 to 6 cans per minute. An operational diagram shows the stages a can goes through in a rotary washer. It starts with loading the can inverted. Then pre-rinse, detergent wash, rinse water, hot water sterilization, blast steaming, hot air drying, and finally unloading, inverting, and placing the lid on. In operation, the can is loaded inverted. It is rinsed with warm water, which is drained. It then gets a high-pressure detergent solution treatment at 65 to 70 degrees Celsius to loosen the milk film. The wash solution is drained back to its tank. This is followed by a hot water rinse at 65 to 70 degrees Celsius, blasting with dry saturated steam, drying the condensate with a hot air blast, and finally unloading, inverting, and placing the lid on. The advantages of a rotary washer are its simple construction, use in smaller dairies, less floor space, and ability to wash cans of any size and shape. A disadvantage is the difficulty in avoiding recontamination of cans by the washer or operator. The other type is the straight-through can washer. This carries cans in a straight line on a continuously moving conveyor or slide. The cans move intermittently from one jetting position to the next. The capacity is higher, at 6 to 16 cans per minute. A diagram of a straight-through washer shows its components: a drip saver, pre-rinse, cold rinse, hot wash, water inlet, steam out, close in, and an air heater. The process flow is shown from the imperfect empty can entering after dumping, through various tanks for rinsing and cleaning, to steaming, hot air blast, and finally, inversion and conveyor to the loading point. The working sequence has 10 positions. Position 1 is loading. Position 2 is pre-rinsing. Position 3 is rinsing. Positions 4 and 5 are for acid cleaning at 65 to 70 degrees Celsius. Positions 6 and 7 use hot water at 80 to 90 degrees Celsius. Positions 8 and 9 use steam at 107 degrees Celsius. Position 10 uses air at 124 degrees Celsius. The advantages of a straight-through washer are its use in large dairies, easy accessibility for maintenance, and no recontamination of cans by the operator. The disadvantages are that it occupies more floor space and requires close inspection during operation. The power requirement for washers includes steam, water, and electricity. The factors affecting this are the type of washer, the capacity of the pump, the number of jets, the number of treatments, and the temperature. For a rotary can washer, the power requirement is about 1 kg of steam per can, 8.7 liters of water per can, 0.85 kilowatt-hours of energy per 100 cans, and an 18 horsepower boiler. For a straight-through can washer, the power requirement is 0.85 to 1.8 kilograms of steam per can, 4 to 4.5 liters of water per can, 1 to 2.4 kilowatt-hours of energy per 100 cans, and a 23 to 43 horsepower boiler. Finally, selecting the right can washer depends on several factors. These include the required capacity, the quality of drying necessary, the available space, the steam requirement, the boiler capacity available, the relative cost of steam and electricity, the relative cost of manual versus mechanical washing, and the facility requirement for maintenance. Thank you for joining this comprehensive overview of can washers, a fundamental tool for maintaining hygiene in milk collection and distribution. Understanding their operation and selection is key to ensuring product quality and safety. Author, Mohr. Techie. Thank you. See you in the next class.